In this video, we're going to look at representing vectors in R3. So it's very similar. It's basically the same as we did in R2, a two-dimensional vector in R2, but now we're looking at a three-dimensional vector. So we can represent a vector, OP, in R3 with a directed line segment starting at the origin and ending at point P. That's the same as R2. The only difference is now this point P will be in R3. So there'll be three coordinates x, y, and z, and we'll look at an example where we do this to give you an idea of what that looks like. Another thing that's slightly different in R3 than R2, although very similar, is we have these standard unit vectors in R3, except now there's going to be three. The I vector is still the unit vector along the x-axis. Because it's R3, it will now be 1, 0, 0. There's a third coordinate. J is still the vector along the y-axis. And now we have a third unit vector, which we will call k, and that will be the vector along the z-axis. So I is the unit vector starting at the origin going along the x-axis. J is along the y-axis, so that's J. And then now we have K. So this would be your K vector. So this was I. Okay, so we have those three unit vectors, those three standard unit vectors. So now let's look at an example where we want to sketch the vector v, which is 2i plus 3j minus k. So I've written v using these three standard unit vectors. So you need to know that that means that's the vector 2, 3, minus 1. So the coordinates are just the coefficients of ij and k, which is the same as what happened in R2. So what we need to do first is, or really all we need to do is plot this as a point and then make it a vector. So we already saw how to plot a point in R3. So now we're just going to add the element of making it a vector. Okay, so 2, 3, 1. So 2 along the x-axis. So this will be 1. So this would be the point 2, 0, 0. And then 3 along the y-axis. So that's 1. So this would be 3. So that's the point. So we got the point 0, 3, 0. And the point over here, 2, 0, 0. Now I have to go down, or maybe what we'll do here is we'll draw that box, or that point. So that's the point 2, 3, 0. And now I need to, on the z-axis, go down 1. So I've drawn the positive z-axis. I need to continue this into the negative. So negative 1 would be down here. So now I have to turn that into a rectangular prism. So there's my rectangular prism. And the point I'm looking for would be this one, 2, 3, minus 1. So this point here. So my vector that I'm looking for, v, starts at the origin and ends at 2, 3, 0. 2, 3, minus 1, sorry. So I'll have to draw that as a vector. And that would be my vector v. So again, when you draw this vector, you have to do this rectangular prism in order to create the illusion of depth for this vector, the illusion that v is coming out of your page. If you didn't have the rectangular prism, you wouldn't be able to see kind of where v is going in R3.